In 1.6, we're going to be looking at some linear inequalities. So for part 1 here, I want to work with some simple inequalities, kind of talk about some notation, different things. So you can see here, I've got just a number line graphed here, and we're looking at values that start at 4 and go on to the right. You can see the arrow goes to the right, meaning everything up and up and up and up above 4, not just stopping at 11, but going on to a positive infinity. If it had gone this other direction, we would be looking at going to negative infinity. So there's a couple of different ways that we can write it. We can first say that x is greater than or equal to 4. We say equal to because this dot is colored in. And then we have other ways that we can write this inequality in other notations, such as maybe set builder notation. Set builder notation has a curly bracket, x, straight up and down, and then our inequality, x is greater than or equal to 4. You include the set or these curly brackets here to identify or indicate that it's a set of numbers. This reads as x such that, and then it gives you kind of the conditions that x needs to meet or to be within the set. And so set builder notation, you're typically going to see your brackets, x such that, and then you've got your conditions here of what x values or how x can fit into that. Another type of notation you're going to see is interval notation. So again, we're looking at x is greater than or equal to 4. So that means starting at 4 and including it, so we write a 4 with a square bracket, comma, up to, you can see up here that it was up to positive infinity, so we say comma infinity and we put a parentheses. Now you always include a parentheses when you're talking about an infinity. Whether you use a bracket or not is whether you include it. Infinity is never a number we can reach, so we're always going to use parentheses on it. If this had not been equal to, we would also have a parentheses on the 4. But since we want to be equal to the 4, we put a square bracket. And so you need to be careful as you work through these problems. Make sure you read them completely and you look at what kind of notation it wants you to use as you go throughout. And I'll emphasize that on the examples to come. So let's look at these two examples here. Example number 1, use interval notation to indicate all real numbers greater than or equal to -2. So I want all real numbers, that means on my number line, greater than or equal to -2. So let me note it on a number line what this would look like. Here's -2. I want everything greater than it and including it. And it says interval notation, so we're going to be looking at this notation here. So I would say bracket, -2, comma, infinity. Look at this next one. Write the interval expressing all real numbers less than or equal to -1. So I'm saying x is less than or equal to -1, or greater than or equal to 1. So I would say x greater than or equal to 1. Now these are simple inequalities I could draw, or if you like, I could also draw a number line and also show you these values. But this says write an interval, so I'm going to have to use this interval notation. So I'm going to say I want from -infinity all the way up to -1, including it. So I would say -infinity, comma, -1, square bracket. Union with, we do just a U without like a stem on it to represent or and give another notation. Now I'm going to go from 1 to infinity, so I do square bracket 1, comma, infinity. Again, we always use parentheses on the infinities, and we always use brackets if we want to include the value. If this had not been equal to on both of these, then I would have used a parentheses. And then when I have more than one notation like this, I do a U to kind of union or marry these two together. So now that we have an idea of notation, we've got interval notation, set builder notation, or just our inequalities and number lines. Let's look at what kind of properties we have with these. So part 2, properties of inequalities. First of all, we get our addition property. Now addition property is nice because just like when we were solving for x, it says if we add something to both sides, then it does not change the value of the equation. This is great because if we were looking at this and we just had an equal to right here, our normal steps of operation would be add 1 to both sides. But on this one, since I have the inequality and because I have this addition property, I also just get to add 1 to both sides in order to solve. 6 and 1 give me 7. You can see I kept the sign exactly the same and an x. And then that would be my answer depending on what they wanted to do with it next. Now in this next one, I would have to add 2 to both sides. I'd get 3x is less than 3, and then I would divide by 3. So you can see in these first two problems, solving for x was just like when you're solving an equation. You can see having this symbol in here just went along for the ride, didn't change anything. But we get something known as the multiplication property. Now here's what the multiplication property says. In general terms, it says if you have an inequality and c is greater than 0 or c is a positive number, you multiply by c, no big deal. But it says if c is less than 0, meaning it's a negative, then you'll notice that this sign has to flip around. Or I like to state, if you multiply or divide both sides by a negative, flip the sign. So when you're solving an inequality, you're going to solve it just like you solve a regular equation, but if you multiply or divide both sides by a negative, you have to flip the sign. So notice, I'm going to add 1 like no big deal. I get negative 2x greater than or equal to 6. I only add it. But now I'm dividing both sides by a negative, so I would get x. This sign needs to flip the other direction, negative 3. So this would be my answer. You'll notice up in this one, yes, I did divide by 3 in this example, but it was not a negative, so my sign remained the same. If you multiply or divide both sides by a negative, then you can see the inequality needs to face the other direction. Let's do this last one here. Solve 4x plus 7 greater than or equal to 2x minus 3. So I'm going to get x by itself. So I'm going to move the 2x over. Now our steps don't have to be the same. You could have moved the 4x over if you had liked. As long as you flip the sign, if you multiply or divide by a negative, we'll all get the same answer. So this gives me 2x plus 7 greater than or equal to negative 3. Subtract 7 gives me 2x greater than or equal to negative 10, and divide both sides by 2. So you can see that I never multiply or divided both sides by a negative, so I just have x is greater than or equal to negative 5. But let me show what it would look like if I had moved the other direction. So I'm going to work this problem out. I'm just going to do different steps along the way. So instead of moving the 2x over, I'm going to move the 4x over. So I'm going to purposely show you how I get a negative in there, and also how I purposely get the same answer. So this gives me negative 2x minus 3, so I'm going to add the 3. You can see my steps are just a little bit different. And then here I'm going to have to divide both sides by 2, give me negative 5. This sign has to flip the opposite direction in x. So in this way of solving, yes, right here I did divide both sides by negative 2, so I had to change my sign, but you'll notice these answers are exactly the same. You can see that the inequality is facing the x on both of these. So if our steps are different, but we're both mathematically correct, then we should both get the same answer. So here's one putting both the properties together. It says solve the inequality and write the answer using interval notation. So I'm going to go ahead and move some things around. I'm going to subtract the 1x from both sides. Again, your steps may look different, but we should all get to the same answer mathematically. So this cancels, and this gives me negative 3/2 x plus 4 less than 1. Subtract the 4. Gives me negative 3/2 x less than negative 3. And then divide by negative 3/2. Now don't let the fraction freak you out here. Just use your calculator and go in there and type negative 3 divided by parentheses negative 3 divided by 2. Type that straight into your calculator and you will get x and 2. And since we divide it both sides by a negative, I'm going to have to face this sign the other direction. Now this is just an inequality to represent all the answers. I need to use interval notation now. And so x is greater than 2, so I would say 2 comma positive infinity. This would be my answer. Notice this time I used a parentheses on the 2, and this is because it was not equal to. So we're going to go all the way up to 2 but not touch it. So don't let the fractions freak you out. Just use your calculator. Use it accordingly. I always recommend using fractions and parentheses when you're using your calculator. Solve the following inequality and write the answer again in interval notation. So I'm going to move some things around. I'm going to use my calculator to help me out with these fractions as I go. So I'm going to subtract the 2/3 x. This gives me negative 5/8, negative 3/4. Again, I'm going to say negative 3/4 divided by negative 2/3 in my calculator. This outputs negative 17/12. And if you're using a scientific calculator like I use, you can do fraction to decimal, and it will tell you this improper fraction from your calculator. Then once I get to this step, I'm going to divide by negative 17/12. Divide by negative 17/12. Again, use your calculator. So x, I divided both sides by a negative, so I'm going to have to flip that sign. This divided by this, using my calculator, gives me 15/34. Now again, interval notation, so I would say 15/34, it is equal to, so bracket, x is less than all that, so I would say negative infinity to that number. So, as you're working these problems, make sure that you use your calculator appropriately and you answer fully, in this case, interval notation. Last two problems, just kind of putting everything together here, compound inequalities. When you're working with a compound inequality, you're going to notice that you have more than one inequality. So the general rule for this is whatever you do for one side in order to get something by itself, do for all sides. And so here's my inequality here. So I have three sides to this problem, and I need to get x by itself. So in order to get x by itself, I would have to subtract 2. Notice I'm going to subtract it from all three sides. 3 minus 2 gives me 1. A 2x is left in the middle. 6 minus 2 is 4. I just subtracted. I did not divide or multiply by a negative, so I'm going to keep the symbols the way they are. Next, to get x by itself, I'm going to divide everything by 2. So this gives me 1/2 less than or equal to 2x divided by x just gives me x. 4 divided by 2 gives me 2. And I got x by itself, and here would be my inequality to represent those answers. And in interval notation, this would be 1/2, it's equal to, so I won't square bracket, comma, all the way up to 2, but not including 2. And this would be the interval notation that goes with that question. Now in the next one, it says solve it and with variables in all three parts. So again, whatever we do to one side, we have to do to all three. So our goal is to get x by itself. So the first thing I'm going to do is I'm going to move my x's around and put them all in one place. And we want to get them in the middle here. So I'm going to move this x right here. And to move it, I have to subtract x from all three sides. So I get 3. 7 minus 1 gives me 6x minus 2. 5 minus 1 gives me 4. Minus 10. And now I'm going to move this one inside. So I'm going to say minus 4x, minus 4x. You can see that when I go to subtract 4x from this side, now I'm just kind of moving stuff around. I'm still in an x with two places. So when you have x in three spots, you're going to have to split it up. Just look at the front two. So this would be 3 plus x is less than 7x minus 2. Or we're also going to look at this other side. 7x minus 2 is greater than or equal to 5x minus 10. So when you have it in all three parts, your letter, you can see how this can go in circles, so separate it out. Now I'm going to solve both of these accordingly. Just moving things around like we did in previous problems. And you can see that I get 5, 6 is greater than x. I'm going to solve this one out as well. Gives me 2x minus 2, negative 10, add 2 to everything, and divide. So x is greater than negative 4. So what this shows me is that x has to be greater than negative 4 and less than 5/6. So putting this all together, this would be the inequality that would reflect this answer. You'll have to split it into 2, or as an interval notation, it would be negative 4, 5/6. So let me know if you have any questions on this lesson along the way.